Hi, my name is Vikram Sivasalam and I am from Continuum Blue Limited, a COMSOL certified consultant. Today, I'll be presenting our cable builder tool which helps to build subsea cable models for analysis. With thousands of miles of subsea cable being produced each year and laid across the world's oceans, it is important to ensure that these cable structures are designed to take the load that they are exposed to during installation or service. This is where subsea cable manufacturers can, with the help of our cable builder tool and COMSOL multiphysics, analyze and assess their cable designs under various load conditions. Allow me to demonstrate the use of our cable builder tool, which can, from client-supplied cross-sectional drawings and a specification sheet, build a full COMSOL multiphysics model ready for stress and fatigue analysis. Here is a typical example of a subsea cable cross-sectional drawing which details the design requirements of the cable. These include external reinforcing structures which can be woven Kevlar layers or multiple layers of counter-rotating steel armor wires as seen in this design. In this particular design, we have a number of hydraulic hoses as illustrated by the numbers 1 to 5. Some quad cores and data cables as illustrated by these items here. In addition to these, there are also a number of fillers and rope ballasts which help maintain the structural integrity of the cable design. From this drawing file, we can obtain dimensional details and component layouts as required in the design. The client also supplies a specification sheet which describes the materials present in the system and the load cases that needs to be assessed. Once the drawing file and the specification sheet have been provided, we can then use the Continuum Blue's cable builder tool to generate the complete COMSOL model ready for analysis. Here is the interface of the cable builder tool. The tool is developed in MATLAB and uses LiveLink for MATLAB to seamlessly integrate with COMSOL multiphysics. We start using the cable builder by clicking on the button marked Input Data from the specification sheet over here. Then we locate the project specification sheet and click Open. This will then provide the input data to build a schematic of the cable cross-section, highlighting the various predefined components as shown in the 2D image. Once assessed, a window pops up asking if this is the correct cable cross-section. We can then compare the schematic against the supplied drawing to ensure that this is the case and that all the components are correctly positioned. There are panels below the image to help assess and compare the cable design requirements, such as color key for the components, internal and external dimensions of the cable, and lay data such as pitch lengths of various cable layers. You will notice that only half of the internal components are shown. This is because the cable builder tool assessed that symmetry is applicable. Once happy, we can then proceed by building the symmetric section of the model by clicking on the symmetric tick box here and selecting the appropriate symmetry condition. This then generates the full cross-section of the cable in 2D as well as generates a 3D representation of the cable design. While generating these, the cable builder also checks the internal structures to ensure that there are no issues such as intersection or overlapping components. If there is an issue, a message will be displayed indicating that a problem was found and the user is required to check the design specifications. If no issues are found and we can confirm that this is indeed the correct cable layout, then we are in a position to generate the COMSOL model. This is simply done by clicking on the Generate Cable button. Typically, the cable builder takes 3 to 9 hours to generate a complete COMSOL model ready for use. The length of time varies depending on the number of components, contacts, the complexity of the internal structures, and the computational resources available. This model took just over 6 hours to generate. Once complete, the user is presented with a complete COMSOL model as illustrated here. The model comes in fully parameterized and makes use of selections, probes, and other COMSOL features. The complete list of parameters is shown here and includes parameters for dimensions, study loads, material properties, meshing, solver settings, and much more. In addition to this, there are a number of switches implemented in the parameter section to help the user activate or deactivate or control certain nodes in the model, such as displacement constraints. To highlight some of the features, we will drop down the model tree and investigate further. In the probe section of the console, a number of probes have been implemented, such as maximum stress, which can be monitored during the analysis. A list of selections is also made to identify different components and material groups. Since there are hundreds of components present, assigning materials to each of them can be a tiring process. However, in the materials section, the materials are fully defined and make use of selections created along with the material parameters already defined in the parameter list, making things effortless. The console model built by the cable builder also features 3 available mesh options, as seen here. As I mentioned earlier, mesh parameters have been implemented in parameter section of the model tree, allowing the user to have complete control of the mesh. A number of study options are also implemented in the model, giving the user a choice of studies with pre-built solvers and scaling of dependent variables, all controlled from the parameter and variable section. Once the user has finished running a study, a number of pre-built plots are available to visualize the results. These plots also come with their own view settings, again controlled from the parameter section. These view settings automatically hide certain domains and/or boundaries based on the selections to ensure that the results plot only display the appropriate plot regions and components. Included in the results section are a number of export features which output the results into the project folder, helping us to provide our clients with images and animations as per their requirements. Some examples of these exported images are illustrated here. We at Continuum Blue also perform analysis on subsea risers, cable joints, and thermal analysis on substations. This concludes my presentation on the Cable Builder tool, a tool to build console multiphysics models faster, smoother, and most importantly, cost-effective for subsea cable analysis. Thank you for listening. Once again, my name is Vikram Sivasalam from Continuum Blue. To find out more of who we are and what we do, visit our website at www.continuum-blue.com.